In today's lesson, we're going to learn about exponential functions, and we're going to start off by learning about how to graph those functions. So the very top portion here has a definition of an exponential function and a couple of examples about how to graph exponential functions. So pause the video now and read over this information. Okay, now that you've had a chance to do that, let's do a little bit of practice. So let's look at the first example, or first problem rather. It says graph y equals 0.3 to the x power. State the y-intercept. Then use the graph to determine the approximate value of 0.3 to the negative 1.5 power. Use a calculator to confirm the value. So the first thing we're going to do is we're going to make a table to help us graph that. And so you can pick whatever values you want for x, and then we'll substitute them into the equation to figure out the corresponding y values. So I'm going to pick negative 1, 0, 1, and 2. So I'm going to find y. What is y to, y equals 0.3 to the negative 1 power. I'm going to do 0.3 to the 0 power, 0.3 to the first power, and 0.3 squared. And I'm actually going to use my graphing calculator. And if you have a graphing calculator at home, you can use that to help you figure this out, or any calculator. You can also use Desmos on your iPad. Okay, so 0.3 to the negative 1 gives me 3.3 repeating. So I'm going to estimate it about 3.3. And then I know any number to the 0 power is always 1. Any number to the first power is that number. And then I'm going to do 0.3 squared. And that gives me 0.09. Okay, now that I have a table of values, I'm going to come over here and I'm going to graph it. So the first ordered pair I'm going to plot is negative 1, 3.3. So that's left 1, up 3.3. Now, be careful because it looks like on the y-axis we're counting by 2's. So if that's a 2, then the 4 would be right there. So that's left 1, up 3 1/3. So maybe right about there. 0, 1 would be here, halfway. 1, 1 comma 0.3. It's going to be about here, and 2, 0.09 is right about here. So this one's going to kind of look like this. Now, when you're doing an exponential function, when you're graphing an exponential function, it's always going to have that curve. If you look at the two examples up here, the exponential functions are always going to be shaped in the same kind of format, the graphs of them are. So that's kind of how I already knew it was the way it's going to be shaped. Kind of like an L shape, but not a strict L shape, okay? Let's try another one. Let's back up. We forgot to state the y-intercept. So the y-intercept here, we can see really easily in the table is 1. So I'm going to write that. The y-intercept is 1. And we're not going to worry about this next part, okay? All right, now let's try another one. Let's look at number 2. For this section, it says to graph each function and state the y-intercept. So again, I'm going to come over here and I'm going to make a table and pick some values. So I'm just going to pick, let's do negative 2, negative 1, 0, 1, and 2, so you can get a few extra examples. So I'm going to find, I'm going to do each of these in my calculator, but I'm going to do y equals 3 to the negative 2 power plus 1, y equals 3 to the negative 1 power plus 1, y equals 3 to the 0, 3 to the first, and 3 squared. Okay, so I'm going to type 3 to the negative 2 power plus 1. and I get 1.1 repeating, so I'm just going to round it off. Now I'm going to do 3 to the negative 1 power plus 1, and that's 1.3 repeating. 3 to the 0 power is 1. 1 plus 1 is 2. 3 to the first, let's do this. 3 to the first power is 3. 3 plus 1 is 4. And then 3 squared is 9. 9 plus 1 is 10. All right, so first I'm going to plot negative 2, comma 1.11. So that's left 2, and then that's going to be right about here. Again, look at that y-axis. Looks like we're counting by 2's again. Okay. Negative 1, comma 1.33. So that's left 1, and it'll be up just slightly. 0, 2. Then it is, let's see, 1, 4, and then 2, 10. And you do need to have those arrows. All right, and what is our y-intercept? Well, we can see, again, from this table, the y-intercept is 0. I'm sorry, is 2. Okay, so now I want you to do 3 and 4. So pause the video and do problems 3 and 4, then come back and check your answers. Okay, welcome back. So here is what I've got for problems 3 and 4. You're going to need to pause the video and make any necessary corrections. So go ahead and do that now. Great. All right, so we're not finished with our introduction to functions. So if you go to the next page, we have some more information about how to identify whether a function is displaying exponential behavior given a table. So let's pause the video and read over this information now. Okay, so the next set of exercises just says to determine whether the data in each table display exponential behavior and explain why or why not. So the simplest way to do that is just look at the patterns in the x and the y coordinates. So for the x coordinates on this one, looks like I'm adding 1, adding 1, adding 1. And that's what you want to see. You want to see a consistent pattern in the x's. Now, for the y's, you want to look and see, are we adding the same amount each time, multiplying by the same amount each time, or neither? So if I go from 5 to 10 to 15 to 20, I have added the same amount each time. That is not exponential behavior. That is linear behavior. So determine whether or not this is exponential. This is not exponential. And the reason it is not exponential is because there is a common ratio. A common difference. Or a common rate. Okay, so there's a common difference here, and when I'm talking about that common difference, since we are on the y's, we're increasing by 5 each time, so we'd say that the common difference is 5. A common ratio would be like if I was multiplying by 5 each time, then we would say it had a common ratio. Okay, so let's skip over to number 2 and see if this one is exponential. All right, so first you want to make sure that your x's are increasing by the same amount, and they are. So I'm not concerned with what's going on with the x's, except to make sure that it is increasing or there's a consistent pattern there. As long as there's a consistent pattern, you're good. Now look at the y's. If I go from 3 to 9 to 27 to 81, I'm not adding by the same amount each time. But you might say, well, you're multiplying by 3. Okay, instead of adding. So this would not be a line. This would be exponential behavior. So this is exponential behavior. because there is a common ratio. I'm going to underline that. Okay, and then we can highlight because we're multiplying by the same amount each time. Okay, so when you're looking at a table, if you want to know if it's going to be exponential, okay, basically just look at the patterns in the table. Are we adding by the same amount each time? If we are, that's not exponential. It's actually linear. Or are we multiplying by the same amount each time? If we're multiplying by the same amount each time, that is exponential and has a common ratio. Okay, so what I want you to do now is you're going to do the same thing for the rest of these problems. So 3, 4, 5, and 6. Remember, you need to say either this is exponential or this is not exponential, and you need to tell me why. There is a common difference or there is a common ratio. Okay, so pause the video now and complete 3 through 6. Okay, hopefully you guys did well with this. Remember, when you're looking at a table and you want to know if the table is displaying exponential behavior, look at the Y column and see if you have a common ratio or a common difference. Are you multiplying by the same amount each time, or are you adding by the same amount each time? And that'll determine it. Just if it's a common difference, know that the graph is going to be linear, meaning a straight line. If it's a common ratio, then it's exponential. Okay, so if you have questions about any of these problems, remember to see me for help. Go ahead and turn this in once you've finished, and then you'll be ready for your independent practice. Good luck, guys.